Okay, so I have discovered why that happens. Basically, I'm creating my texture within a function. So by the time this function returns, the texture is destroyed. So now we have learned from my mistake that the textures always have to be declared in the main function. So I'm going to remove the declaring of the textures from this function, and I'm going to place it in the main function underneath our comment from our skeleton that says declare all variables I need here. So I'm going to declare my textures. Let's add a comment برضو. Declare textures. Okay. And now I have to send the textures into the function if I want to use them, because we can't create them in the function because it disappears. So let's add them to the function definition هنا. Texture and a grass, and then texture. Any texture I want to use, I have to pass it in, and then let's send them into the function here. Grass and then brick. So yeah. Grass, oopsie. Layer Y and then grass and then brick. Let's see if that worked. Very good. Okay. Back to our drawing function. I could do that, and then I could do window.draw. Let's see what happens. Maze. I think you're starting to see the pattern of how we're going to draw our maze onto the window. Let's see what happens. It's drawn on top of it. Okay. Why is this happening? Why am I only seeing one brick here? It's because of the set position. Yes, the second brick, when I set its position, it's set a little bit underneath it, but because the size is so big, okay, what ends up happening here is brick here at index 0, 0, the position بتاعها, I'm setting it at position 0, 0, pixel 0 and 0. And then I'm drawing the second one, and its position is also at 0 and 1. But I'm only making them a difference in 1 pixel, when in fact the picture of the brick is probably hundreds of pixels large, so my eye can't see the difference. But when I set the position, I need to multiply it by some factor so that I can see. Let's try. I'm gonna do 100 because and I'll make my window of size 700 and 700 so they can divide easily. If this doesn't make sense, like, you can mathematically calculate it or just trial and error. Let's see, I should see something now. Good, see, it's starting to show. But there's no way I'm gonna fill in my 700 by 700 window with 49 of these. They're just way too big. So I need to scale them. I need to make them smaller. But let's scale them. I'm going to do maze at I and j dot scale, I believe the function was called. Again, where did I get this idea? How do I know what functions I can use to apply to my sprite? As always, the documentation will tell me everything I need to know. I'll go on classes, I'll search for sprite, and this documentation will tell me all of the functions I can use on my sprite. We already used set texture, that worked. There's set scale, I'm using just scale, I think that one will work. If not, then the documentation will tell me it's set scale. I believe, yeah, scale, see, I knew it was like something like that. But these are all the functions I can use on my sprite. Again, always read the documentation. Okay, so scale, we have to make it smaller. The scale function multiplies the dimensions by whatever number you give it. Then I'm saying make it half. Make my sprite half of its size. And again, I have to do the same thing here. Remember, this is if it is brick. And then here, if it is anything else. Again, I have to scale here. Maze at I and j. Oops. Dot scale 0.5, 0.5, and let's just see if this makes anything better. Much better, but maybe they can be a bit smaller because they're still kind of overlapping, right? Let's do 4.7. See, it's really trial and error. Okay, now that that looks better. That's fine. But let's draw all of it. You're starting to see the pattern here, right? 0, 0, 0, مش عارف ايه. But yeah, what we need to do, we need to put this in a loop. I equals 0, I less than rows, and then I plus plus for int j equals 0, j less than columns, j plus plus. By the way, there's something, and then window dot draw maze at I and j. Let's see. Oh my god, we didn't set the thing for that. We didn't resize the grass. Okay, we have an issue with grass, but let's see here. Set texture. Oh, we didn't do the times 100. We didn't. Okay, let's explain why that happens. Basically, all of the grasses are being on top of each other and they're only moving slightly because I'm setting their positions with a factor of 1 pixel. But we need to multiply so they can have a chance to show, you know? I hope that makes sense. Okay, that's good. However, is this the same thing as my text file? I don't think it is. Let's see. It's not. My text file, see how the H's are here? It should be over here. This is actually rotated. Every column becomes a row here. So why is that? Why is that happening? It's because the set position function in SFML. Let's go to the documentation and try to understand it. The X position. But I and J aren't X and Y positions. They're actually row and column positions. But in fact, okay, how do I explain this? Okay, this hedge here sits at row 1, 2, 3 and column 1, 2. Its Y position, its X position, it sits at, it actually sits on the X axis, it sits at 2, it doesn't sit at 3. On the Y axis, the height is at 3. The way in C++ when we think of I and J, row and column, in the real world, X and Y position, they're the opposite, makosin. So the position actually is J and I, and J and I. If this doesn't make sense, don't worry about it. Hopefully when we do the move function, this same principle it's gonna show up again, and if not, trial and error. Trial and error. And you'll notice if you make the same mistake that I just made. Now that's my maze that I was talking about. Because if you had made the same mistake that I did, you're gonna be like, Ida, that's not my maze, and you're gonna analyze it. And you're gonna notice that it's different. You're gonna trial and error and see, oh, then I must have set the position in the wrong place. But that's just like some theory as to why that happens. It's because when we think of rows and columns and I's and J's, it actually isn't. It's not really X and Y positions. Again, let's think about it. Take this little h here. Actually, let's do this g because so it can be a different one. Okay, its row, its I is at 1, 2, 3, 4, or 3, 0, 1, 2, 3, and its j is at 0, 1, 2. But if we think about this as x and y axes, like SFML thinks about things, actually the x position of it goes like this. This is the x-axis and this is the y-axis. So where is it at the x-axis? It's at 3. And where is it at the y-axis? It's at 0, 1, 2, 3, like that, like 4. Right? So do you see how it's flipped? Yeah, that's just how SFML thinks of things in terms of x and y axes. And in C++, we think of things in terms of rows and columns and i's and j's. But like, just hopefully keep that in mind. Okay, so now we have our maze initialized. Let's draw the player on top of it. And only this function has to do the player. So now this loop did the maze. And we've set the player x and y here. So let's initialize the player. It needs its texture. But let's send the texture for the player, like we did player, I guess. And then down in the main function, like we said, we have to create it in the main function because we discovered why it needs to be like that. But I'm just going to copy this, change the name player. And then I remember what did I name my player in my file? I named it player.png. Player.png. Okay, and we need to send it over here. player, right? Oh, okay. I have, the names are different. I named my sprite player. If I need to name it player T for a texture, I need to give them different names. Player T. And أكيد هنا there's going to be an issue for player T. Textures player T. Okay. So we're done with the maze here. So let's do now initialize init player. Okay. So my player is a sprite هنا. This should be by reference, so we can be allowed to change it. Right? Yeah, that's fine. Okay, so player dot set texture, player T, and player dot set position, because remember, to initialize a sprite or anything, we set a texture, we set a position, and now we set a scale. Set position, player X, which we initialized here. Remember, when we came across the E in our text file, we knew that that's the position of our player. The player X and player Y. And we're going to multiply by 100. عشان أنا ظبطت my pictures such that all of my pictures are the same size. Yeah, there's going to be a chance we're going to have to reverse these because of what we just said. I hope you guys noticed that. Set scale, or no, it's just called scale, 0.47, 0.47. And then to see, now I've initialized my player, let's check my work by drawing the player on the screen. And we go down under this comment like that we saw in our skeleton, window.draw player. I hope that's what I named the player sprite. Is that what I named it? Yes, okay. Hopefully we should see our player. It's way too big. So why is it too big? And also, why is it too big? We need to make it a bit smaller. Again, trial and error, you just keep changing the number until you find it, but I remember I did this before and it's 0.2 is what my particular picture needs. It needs to be scaled to 0.2. Yours will need something different, you just keep playing around with it. And my player is actually in the correct position. And why is it in the correct position? It shouldn't be. It's probably because these are symmetrical. Yeah, it's because they're symmetrical, but you have to change them. This is confusing. خلينا stick to this. You have to change them. J and I, remember, because we said SFML changes. It's just a coincidence because I happen to have my player here at something, its I and its J are equal. This is at 0, 1 and 0, 1. So that's why I didn't get a mistake, but it has to be changed. You always change your J and I's, like, depending on how you like conventionally have it, but like I follow the normal conventions that we do, and with these normal conventions of, oh, it's another mistake, but again it doesn't matter because they're the same. Sorry, forgive that mistake. But yeah, just watch out for that and really try to understand the difference between SFML's X and Y and our C++ I and J. But yeah, okay. So now our board is initialized. Notice the player is being drawn on top of the maze. But now I want to move my player. Let's focus on moving the player.